Welcome to part 2, where we're going to jump in right where we left off, and we're going to kind of jump into the training, the testing, the evaluation, and kind of the refinement of our model. So we're first going to start off by just using a random forest classifier, which is one of our classification models that we can use. And then we're going to start looking at maybe if there's different hyperparameters that we can tune, so we can kind of tune how the model works, or we can start adding more features, or we can start even try using a different data set. Okay, so let's go ahead and we are going to just import our first packages that we need. So we'll say from sklearn.ensemble, okay, import random forest classifier, and we'll say from sklearn.metrics, import accuracy score if I could spell, and then from sklearn.metrics, again, import our confusion matrix like that. So we'll import those, and then we're just going to basically split our data into test and training data sets. We're actually not going to use the train test split method because we're going to do just a manual train test split because it is this time series data that we're working with. So if we look at all of our columns, so we'll just say df.columns right now, these are all the columns or features that we have available to us. So our result column obviously is what we're trying to predict, and then we just need to basically choose what we want to include in our actual model. And since we have so many features, it's actually easier just to tell it what we don't want to include. So what we'll do is we're just going to create a list of features. So we'll just say features equals, and then we're going to create a list of the columns we want. So we'll say column for column in df.drop, and then we just want to tell it which columns we don't want to include. So say columns equals, and then we are going to drop the date column, we'll drop the xg column, okay, we'll drop xg.1, we'll drop home, we'll drop away, and then referee, we'll drop venue, we'll drop the score, result, because we don't want to include our actual result column. And then I'm just going to hit enter before this column so it goes into a new line. Then I'll hit enter again, after this columns. And then we also want to drop the home goals, okay, and as well the away goals, and then season underscore start, like that. And then add your bracket, and then add the parenthesis right there. And then we need just to add our last bracket as well to close that off. So if we run this, and then let's look at what our features are now. So these are all of the columns we are going to use to actually predict our model. So we're going to be using the week. We're going to be using just Friday, Monday, Saturday, Sunday, all those. And then our rolling average goals and our rolling average expected goals. Essentially, this is the reason why we drop some of these, is because we're going to come back and see if we can use some of these other columns to improve the model later down the line. So we're just kind of starting off with a bare bones model. So the next thing we'll do is we'll just split it into training and testing data. So we'll say train underscore data equals df season underscore start, okay, is less than or equal to 2022. So we're going to use anything where the season started, basically anything before or equal to 2022 and earlier. So go ahead and close that off, and then we'll say test data equals, and we're just going to use the 2023 season to basically use as our test data. So just say df season start is equal to 2023, okay? And then we're going to manually create our X train, our Y train, our X test, and our Y test. So do X underscore train equals train underscore data, and then features. Okay, so we pass in this list of features, the columns we want to use, and then do Y underscore train equals train data, and then we just want the result column. okay? And then we'll do the same thing for x test. So x underscore test equals test data features. And then y underscore test equals test underscore data result, like that, okay? So we have just basically done the same thing that train test split does, but we have manually done it, essentially. And if you don't close that off, it won't work. So make sure you close that off, and then we have now successfully created our training and testing data. So if we look at this, we have x underscore train dot shape. Okay, we have 3,767 rows we're using to train the data, and then x underscore test dot shape, we're using 631 rows to actually evaluate and test our model that we create. So now let's actually create our model. So if we just say CLF, so our classifier equals random forest classifier, and then we'll do random underscore state equals 1, and then we'll do CLF dot fit. So we're actually training our model, x underscore train, y underscore train, okay? So it'll output that it has trained our model. So now let's actually make predictions. So we'll say predictions equals CLF.predict, and then x underscore test. So it's made the predictions. I'm going to call it predictions, not just prediction. And now let's look and see what our actual accuracy is. So let's just do accuracy underscore score, and then we'll do y underscore test and predictions, okay? So now that we have come to this, we can see that our accuracy score is 45%, which if you're thinking right now, like, that's less than 50%, you have to remember that we're classifying 3 different objects. So we are above just average, okay? So we're at least above average, which average would be 33% accuracy. But kind of how we talked about earlier, we have something called a baseline model. We want to make sure that we are above what like if we were to just go predict on every row what the most common value is, we want to make sure that we're above that to say that it's a good model. So let's go ahead and let's evaluate what our baseline model accuracy is. So if we say df result, okay, dot value underscore counts, and then we'll say normalize equals true, we can see that our baseline model is 44.5%. So we're just a little above our baseline model, which usually isn't fantastic, but it does mean that we are more accurate than just predicting home win on every single row. So this is where we can start to look at actually fine-tuning and re-evaluating and improving our actual model. So we're going to do this through a couple of ways that we haven't talked about, but the first one is we are going to do something called tuning the hyperparameters of a model. So a model, we've just created this random forest classifier, but this random forest classifier actually has different parameters and things that we can tune to make this better for our actual data set, okay? So let's go ahead and we are going to run a couple of more imports down here. So we'll say from sklearn.model underscore selection import grid search CV. So what this is going to do is we are going to give it a bunch of parameters that it can test all the different combinations, and then it's going to give us what the best parameters are for our model. And sometimes there's nothing you can do to actually improve the model. Sometimes it'll give us better parameters that we can use. So we're just going to create a couple of parameters. So we'll say param underscore grid, okay, equals, and then as a dictionary, we'll say n underscore estimators, okay, and then it's a list of, we'll do 50, 100, 200, and then max underscore depth of 5, 10, 15, 20, and then close that off. So what this is doing is we are saying these are the different things that we can tune and change for a random forest model. So the reason why we're doing this is because we want to actually go ahead and change and test different parameters. And so we can change the number of estimators it's using, which is just a random forest parameter, or the depth of the actual random forest and kind of the nodes that it has in its actual classification and kind of learning, okay? So this would be different depending on whatever model we're doing. Like if we were doing a different model, like a naive Bayes model, then we would have different parameters that we would have to test. So these ones are specific to random forests. And I'll kind of show you as we train a couple of different models and test different models how we can specify which model parameters we're looking at. So go ahead and under this, we'll say grid underscore search equals grid search CV, and then our estimator, okay, is going to be our classifier, and then we'll say param grid equals param grid, okay, and then we're going to give it a CV value of 5. So this is the cross validation. So cross validation essentially allows us to train the model multiple times using different data sets, and then it will test against kind of the same data set over and over to give us a more accurate representation of our accuracy, okay? So do grid search, and then we'll do grid search dot fit, and then x underscore train, and then y underscore train, okay? So go ahead and run that, and it might take a second because it's basically looping over all of these different combinations, and it's going to give us what the actual best parameters are to use. So now that it has done that, it's basically given us our grid search, okay? And we can see what the actual best parameters were and what gave us the best score. So if we say grid search dot best underscore params with an underscore, it's going to tell us that our best option is to use max depth of 5 and the number of estimators as 100. Let's just go ahead and recreate our classifier. So come up here and just copy this code again, okay? So copy where we created the random forest classifier. And then in parentheses right here, just say max underscore depth equals 5 and n underscore estimators equals 100, okay? And then run the fit, and then we'll do it all. We'll do predictions equals clf.predict, and then x underscore test, and then we'll do accuracy underscore score, y underscore test, and then predictions, okay? So if we run that, we can see that we have taken our model accuracy up from the initial accuracy of 45.9% to 49.9%. So just by changing the estimators, we gained about 4% of accuracy. And that's really our first step to improving a model, is by tuning these hyperparameters is what they're called. So it's basically all the parameters of an actual model. So let's go back, and so now we have 49%. We can probably do a little bit better if we include some of the other features that we omitted at first. So let's go back, and we'll say df equals pd.get underscore dummies. So we're now going to create dummy variables for the home team, the away team, the referee, and the venue, okay? So we'll say pd.get dummies, and we'll do df. Then we'll say columns equals home, away, referee, and venue, like that. And then we can just do df.head after we run that. So as you can see, we have now created dummy values for all of these different columns, essentially. So this is the venue one right here. So if we go look at the shape, if we do df.shape, we now have 263 columns or features that we are going to be using in our model, which should help us with our prediction, okay? Sometimes there's a fine balance of too many features and not enough features, so we'll be able to kind of see if we've included too many features, if our accuracy drops, or if the additional features are actually helping us. So we're going to take this essentially in 3 steps. First, we're going to get the training and testing data, again, with our new features. And then after we've done that, we will run the grid search. So we'll look at how we can, or what the best hyperparameters are for our model, and then we'll make predictions. So I'm just going to go back up and copy all of the code because I don't really want to type it again. So let's come back up here and let's take where we created our features, Okay, so take this data or this code right here and come down. So we'll say features, and then we are just going to drop. We can get rid of home and away, referee, and venue like that. Okay, so now we are only dropping those columns, and then let's also go and copy the code which created our training and testing data. Okay, so come down here and just paste that underneath. And then let's also copy our grid search data. Okay, so copy this right here. So we have basically gone ahead and we're just basically putting it all together. It makes it a lot easier if you change one thing, you can just run one cell instead of having to go and run a gazillion cells, essentially. And then at the end, let's just say grid underscore search dot best underscore params to get our best parameters. So this is our new training data and our new testing data. So let's run that. It'll take a second because now we have even more values that we're looking at. So it's going to go through and it's going to run a bunch and it's going to come back and tell us what our best options are. So right here, we can see our best options are max depth of 15 and the number of estimators 200. Let's see if this improved the accuracy score of our model. So our previous accuracy was 49.9, so we just need to make sure that with these changes, we have improved our accuracy score. So let's come down here and let's just do CLF equals random forest, okay? Random forest classifier, and then random underscore state equals 1, n underscore estimators equals 200, and then max underscore depth equals 15, okay? And then we'll do CLF dot fit with X train and Y train like that. And then we'll do predictions equals CLF.predict with our X underscore test. And we'll say accuracy score with Y underscore test and predictions. Okay, so run that. And as you can see, we have improved even further to a 51.8% accuracy. So that is kind of the iterative process of improving machine learning models. We first start off with just a base model, and then we start with some feature engineering, some hyperparameter tuning, some grid search to help us figure out what the best parameters are. And then with that, we can take that and continuously improve and try to get the best version of our model until we feel like the model is doing consistently well. Okay? And there's a ton of different things. Machine learning is really iterative. We could go and we could test different models. We could go and find if, hey, maybe there's a model such as like logistic regression or a naive Bayes that does better. If you're interested in doing that, it's basically you just have to use grid search to loop through all the models. So I have code in the actual GitHub file for this project that'll show you how to do that if you're interested in that. But let's move on to actually just making predictions. So we have our model. We're just going to create a random match. So when you're creating models, the way you have to make predictions is you have to go and you have to basically recreate all of the features that you have put into your model. Otherwise, it won't work if you don't put in the same number of features. So we're just going to create an imaginary match where we say Chelsea is playing Manchester United. So what we'll do is we'll say home team equals Chelsea, okay? And then away underscore team equals Manchester United, UTD, like that. And we'll say referee equals, we'll do Anthony Taylor, okay? So that is kind of setting us up to say, okay, it's a match between Chelsea and Manchester United, and the referee is going to be Anthony Taylor. So let's create our data, okay? So we'll say data equals, and then in a dictionary, so we need our week, okay? And then do a list and put 25, so we're going to be looking at match week 25. We'll just make some data up. We'll say home, rolling, average, goals, okay, and then we'll do 1.9. And then we'll do away, rolling average goals, and we'll do 1.2. And then we'll say home rolling average XG, like that. In a list, we'll do 2.1. These are all data points I've just made up. This isn't real data, right? So then we'll say away rolling average XG is going to be 1.3. Okay. Then we'll do day underscore Saturday is 1. And then home underscore Chelsea is 1. Okay. And then away underscore Manchester United, like that, make sure you have the space in it, is also going to be 1. And then referee underscore Anthony Taylor, okay, is going to be 1. And then the venue, they play at Stamford Bridge, so we'll say venue underscore Stamford Bridge is 1, okay. And then close that off with with your curly brace. So this is just our fake data that we have essentially made up. And we'll say match equals pd.dataframe. And then we'll say columns equal x underscore train dot columns. And then data equals data. And then, so this is going to create a data frame with all of the columns from our training data set. And it's going to give us our data here. So basically, if we don't have those columns, it's just going to be null. So we need to actually fill those columns that are missing with 0 because they're all of the different like stadiums and days, right? So we need to make sure that we have values for those, but they're just going to be 0 because we've already marked the ones that are actually happening as 1. So we'll say match dot fill NA 0 and then in place equals true, like that. So run that, and then let's actually use this to predict what, based on this data, what the actual model thinks will happen. So if we do clf.predict and then match, okay, so we're just passing in our data frame. We can run that, and then it predicts that it would be a home win, just based off the numbers, based off who is playing, and based off these different results, it's going to predict a home win. We could change this and we could play with it and test it, but that is how we can use our model to actually predict values and predict and actually make predictions. So like I mentioned, getting this like into production is a whole different beast that we won't go over here, but this is how you can train your model. And this is how you can actually use it to make predictions. So if I were to go and use this model, I would want to create some sort of way that we can essentially take new data. So say we scraped FBref and we were getting that data, you would have to recreate all of the calculations using like some sort of pipeline or using just a notebook, which will go and recreate the calculations, and then you just feed all of this information into the actual model, and it gives you a prediction for that match, which then you can use in a ton of different ways. A lot of people, in sports betting, for example, in sports betting, this type of stuff is used a ton, and really like a 52% accuracy score might seem a little low, but this is a really baseline model that we have done in about an hour and a half, little under 2 hours. These models, the more you work on models like this, the more you'll really start to understand how you can better play with these models, how you can better get these models and get better data, because really the key part of machine learning is bad data in, you're going to get garbage out, right? Garbage in, garbage out. So you want to make sure that you, one, have good data collection and good data processes to then feed good data into these models so they can learn and then they can make predictions. And this is really just the start of machine learning. That's what this whole project was aimed at, was just helping you understand the kind of the flow of doing one of these kind of machine learning models and projects. So that is it for project 2. I think this is really valuable and can really help a lot of people who are interested in machine learning, AI, and kind of how that's applied to sports, especially football. So that is it for Project 2, and I will catch you. Be sure to leave any questions in the Discord if you have any questions, and that is it for this video.